So I'll show you that quickly now as to kind of where we are going. Is this website shinyapps.io that you can create a free account on. You can host, I think with the free account, just a few apps. And so one of them here is the vaccine dashboard that I built. And here is that comparison plot between Pennsylvania, South Carolina, and some other information as well across all states. That takes a few seconds to render, and a country inequality chart, as well as a sortable data table. And so let's go back to the beginning about how to build something like this from the ground up. So back to our roadmap then of how we can do this is to learn some basic R and using RStudio as an integrated development environment, and then learning how to manipulate data with tidyverse, which is a set of packages for data manipulation, and a plotting package called ggplot. Try to get into an introduction into R Markdown, which allows you to create dynamic reports in R, and then into the analyzing of code vaccine data and publishing it in a Shiny app to show you the architecture of Shiny and how that works. So the first thing is about installing R. So R can be downloaded and installed from the Comprehensive R Archive Network, or CRAN, as you'll hear it called. So you could download R here, install it for your particular platform, and then there is an R programming tutorial on YouTube that I have a link to that I highly recommend. That it gets into a lot of R programming details. And so, of course, here, I'm only going to be able to do so much, show you so much. So I've provided a link there for you. And in R, a lot of the functionality in R is provided by packages, which are libraries of code. That there are a set of base packages already pre-installed, and as well as you can get others from CRAN. And I'll show you how to install some of those within R as we go forward here. There are like over 17,000, I think, packages last I checked on CRAN that are available. So so back to R. Let me show you. So I have the code here downloaded from GitHub, and I'm going to open up the basic R in just the R app that I have installed already. And by doing so, what we have here is the R console here on this left side that shows you what R version you're using, version 4 from last summer. I think I need to get that updated. And over here is the R code from that R script, the .R script basic R. And you can execute lines of code here with a keyboard shortcut. On Mac, it's Command Return. So let's take a look at, everybody always likes to show a calculator for the basic example, 2 plus 2, you can see the answer here is 4. So if I want to look at a default data set called Iris, that it is a data frame of 150 observations showing you the various columns that are available in that data set. There's some numeric columns and a species column. And let's say we just want to get a summary of this data. I'm going to execute the summary iris, and it gives us some idea of the spread of these values in each of these columns and what is occurring in species, the different types of species for these flowers. And plotting functions such as a box plot that we will plot sepal width against the species to bring up a box plot such as this that shows you the spread of the values across the different iris species and what the sepal width is for each of those species. And the black line in the middle is a median value. Now this is in base R, but base R can be a little bit more, for me, a little bit more difficult to work with. There's various windows popping up. They're not all integrated together. And that is why I use RStudio, and we'll use that going forward. I just wanted to introduce you to R because you can really do everything in just the regular R installation that we can do in RStudio. But I'm going to move over to RStudio now. And let's see, don't save that. And I'm going to open up my RStudio, I guess, which I had already sort of had it there. But okay. And in RStudio, when you initially open RStudio up, there are various panes in RStudio. I'm sorry. I do want to go back. Let me take a step back that I have a slide for RStudio, a website for installing RStudio. Let me take you there. And that would be this link here. So you can download the appropriate RStudio application for your platform. I think it automatically detects here that I'm on a Mac, and you can download and install that. And when opening up RStudio, it's a little daunting at first. There's a lot of tabs and panes that are showing up. The one thing I want to show is the help menu here. There are some RStudio docs, this link that'll take you out to the web to show you some documentation. There's even a community forum. And one of these is that I use a lot is the cheat sheets that if you click this browse cheat sheets link, it opens up a set of a website to show you a set of cheat sheets that you can download and look at. And so we're going to be covering some of these things, like, for instance, data transformation cheat sheet, which is part of the tidyverse that is dplyr. And it's just a handy little reference to look at some of these cheat sheets as to what's available in each of these packages. And so back to RStudio, and I'm going to open up the file that I had before, the basic R. Open that up, and now it appears in this pane here. So there are 4 primary panes. Your scripts appear in the upper left here. The console is appearing down in the lower left, where this, when I opened up the regular R software, this was the console you were seeing, and we can type commands down here and hit enter and and get that to display the value 4. Or when we come back up into the script itself and typing a keyboard shortcut such as command return, this would execute the 2 + 2. And that would, and when you look down below, that's where the output will show is the value 4. And we can do 10 to the 3rd power and see the value 1000. Other things such as, I'm going to skip down real quick to, I'm going to skip down to this x is equal to, and right whenever I entered, when I executed this x is equal to this, this vector, x appeared over here in the global environment. This is an area that shows you the variables that are in your environment and what the value of them are. So as I go through this, you'll start to see this global environment be populated. And so this is something in BaseR, the first thing I showed you, that R software, that I don't think there's an environment window to show you this. So this is a handy panel to use to see what is in your environment. Okay, so there's things like moving around your directory structure. You can get the working directory with getwd, shows you where I'm at in what directory. You can set to a new working directory. Here it's just an error because there is no path such as this, but if you put an appropriate path there, you can set that. Getting help. So if you prefix a function name such as mean with a question mark, your help, the help would pop up in this help tab in this pane that contains many other tabs that I'll show you what some of these are. And here is the instructions or the documentation for mean. You can also do a help search function on some string value, like maybe normal distribution. You want to learn more about that. And that will bring you up a bunch of different help pages about normal distributions. Something like this would probably be best for Google, that you would just search Google, hey, show me how to do normal distributions in R, and you'll get a lot of good information there. There's also just a standard help function where you can specify a package such as stats. That's a base package that is part of R. And this is just going through all of the different functions that stats package provides. ANOVA, there's, I'm sure you'd find mean and max and median in here somewhere. So stats really gives you a lot of those mathematical things that you would want. There are also default base R packages that, well, I'm sorry, there is a data sets that are supplied to you that you can work with. One of them, and it's just this library data sets. And if you say, well, give me some help on that package data sets, this just shows you all these different data sets that are available. And one of them is the iris data set, which I introduced you to quickly. If we click on that, Edgar Anderson's iris data, showing you about some of these different flowers. And so here is that that code that I showed before, where we did the box plot of the iris data set, and here is where the plotting window appears. So it's one of these tabs. So we can look at the plots, we can look at the help tab, we can look at our file structure, and so this just shows you the current working directory that we're in. I'm in the COVID dashboard directory specified here. And okay, so other things with some base R functions is just getting the class of this iris data set. It's a data frame. We can look at the top 6 lines of that data frame with head, showing you the top 6. Some other informations about the data frame, like the number of rows, the number of columns, 150 rows, 150 columns, and some other basic plotting functions such as histogram, hist. So hist on the sepal width data. And so it helps you to see any high and low values, kind of what the average value is for that. So about how to install some packages. So one package is just this fun little cowsay package that you use install packages. So let's install cowsay. And so instead of you going out to cran manually and downloading a package and then installing it. Here, just install packages. We'll just pull it from CRAN, download it, install it. And we have to run library cowsay to make this library accessible to our current code. And one of the functions it provides is the say function, which I'm just having our cow say, hello, Hillman Academy students. So hello from the cow. And so other basic data types that R has is a vector data type, where we're going to set the variable x to these to this set of values. And when we highlight, you can highlight code here in this in your script. And when you highlight it, and if I hit the command enter, it will just execute x. And by doing so, you can see that that vector is made up of those 5 values. And you can get, well, what is the type of x? It's a double. It's meaning it's stored as a double data type in R, and there's other types in R. You can sort those values. You can reverse the values. You can get the unique values. So there's a lot of functions that you can use to manipulate those vectors. I think for the sake of time here, I'm going to skip through a few things. One that I want to show is selecting vector elements. So we can subset x with this bracket notation and get the first element, which is the first element is 4. We can get all of them but the third element with the -3, all but the third. And this interesting notation here, which might be a little confusing, looking at this in operator. So this is saying, give me all of the elements of x that are in this set of 2 and 6. So again, if you remember, x has 2s and 6s in it. So if we run this, it will just give you those values of 2 and 6 that are in x. There are flow control such as for loops and while loops in R. I'm going to skip through a few things. There are if-else statements. You can build your own functions, such as this concat function, and I'm going to skip through that. But there are a set of math functions. A lot of these from that stats package. I'll just give you a flavor of this. This is rnorm is a function that you can pull from the normal distribution of values and say, give me 50 of those values. And so by executing this line, x, this is just a random selection from a normal distribution of 50 values. And then you can calculate the mean on that, the standard deviation, and on and on. So, all right, and then moving on to strings. So we can create string values and kind of dynamically put them together. So let's say you got a grade of A here, a score of 94.5%, and as you know, in your code, as a grade might change, that you could just update this variable as well as the score, and then whenever we want to print out the score, we can concatenate all of these values together. You got a score of score, which is grade, and then put this all together with a separator of basically no separation between these values. And that's the paste function. Paste 0 is a specific version of paste that already sets sep is equal to quote, quote. So that's just kind of a shorthand way to write that. And I'll skip down through a couple other things here. Another thing that R uses is what's called factors. It's a way to manipulate character vectors, but allow them to be put into categories that are called levels. So I will create a vector of fruits here. And when we look at fruit, you can see there's 5 grapes and 3 apples in that factor. We can, or in that character string, and we can convert it to factor with the factor function. And then when we get a summary of that, since it's a factor, it can then group those 3 apples together, group those 5 grapes, and show us that information. And I'm going to skip down through a little bit more. Okay, I'll skip over matrices and get on to data frames. So data frames are like a spreadsheet. You saw an example of that with the iris data set. And we can build our own data frame by specifying the column name X and column name Y. I'm going to build it with the data frame function. I'm going to take a look at that data frame by executing just the value df. And we have 2 columns, X and Y. And there's various ways to subset on that data frame, such as just give me the column X with $X. Just give me column or row number 1. So this notation with brackets is anything you have the open bracket, and then you specify rows here, comma, you can specify columns next. So here it's saying give me row 1 with all of the columns. Like if I don't specify a column, it's going to give me both columns X and Y. And other ways to that I'm showing here how to subset a data frame. But I'm going to skip over that and then just move on to some just very basic linear model statistics in R. Just to give you an example of that there is a base R data set called women, where we have women height and women weight. And we can plot that here in the lower right. So the plot of height versus weight. And LM is the function to create a linear model. And what we see in here is a formula with this tilde, W tilde H, which is like y is equal to y, or y is equal to x, or like a linear equation in algebra. Y is equal to mx plus b in a sense. So we're basically saying, find that regression line between weight and height. And so by executing this line, this m variable is the model or fit. You'll hear that word as well, fit or model. And we can then add a b line to the model, which gives us our regression line here. And a bunch of other helper functions on the model M, such as summary, which will give you your coefficient estimates. And so I'm not going to get into those details now, but you can be rest assured that R has a lot of powerful statistical ability to show you the equation, to show you your p-value and other things like that. Okay, so now I want to switch this. So that's some base R stuff. Now I want to switch focus over to Tidyverse, which is a suite of packages that uses a standard format that was developed by the writers of Tidyverse, and that enables the passage of data easily between those packages within there. So, and that data format is usually called, it's usually referred to as tidy data, that this word tidy. So there's an actual package called tidier, we'll use one of those functions in there. I'll show you an example of that. And this is just some of the packages that are included within Tidyverse that I'll show you some examples of these. And I've provided some links here. The link to the main Tidyverse page itself, they have a nice little graphic here just showing how they're all connected together. The plotting package versus the data manipulation package versus the reading of files package, and as well as a data science book that the developer of Tidyverse has made available for free, which is a very, very good detailed book if you really want to dive into. And I'm going to show an example of the chapter 5 for data transformation, where I've pulled some examples to show you from this. And there's also ggplot data visualization chapter that we'll get to some ggplot today. So that's what we're doing next. We're going to do some Tidyverse data manipulation and some ggplot visualization. So let's go back to RStudio and open up Tidyverse. Okay, back up through. All right, we're going to load. I'm going to load some data sets. A library called NYC Flights 2013. So this is a data frame. It's a data set of flights from the year 2013 that we're going to use. There's another one called HMIS, and this provides a package for exploring your data, and I'm going to show you an example of that. I'm also going to load Lubridate. This will help us to work with dates, and Tidyverse itself. So when Tidyverse loads, you can see what packages it's pulling in here, 7 different packages. And you can not worry about these conflicts so much, but what it does show you is that Tidyverse will redefine some base function names, such as filter, like filter. Filter is normally in the stats package. But now when we run filter, it's going to be running the dplyr version of filter. So it's something to keep in mind that when you load Tidyverse, if you load something else after Tidyverse that maybe would redefine filter, and you go to run filter, you may have expected the Tidyverse version of it, but you would get the other package version of filter if it would happen to redefine it. So that's something to keep in mind that when you're loading packages and kind of what order that you load them in. Okay, so a quick note about data exploration with HMIS is the describe function. When we looked at the iris package, I'm going to execute just the word iris, and that shows us our data set of iris down here. Now, for a really large data set, it would be unwieldy really to look through that and to see what all the values are, to get a sense of what your data looks like. What describe allows you to do is you execute describe on your data set, and it will then break down your data frame per column to show you the various variables that you have. There's 5 columns, 150 rows of observations, and just gives you some idea of the spread of those values, how many are missing, and what the value and frequency are of character vectors. So I would highly recommend, whenever working with any data set, is to do some exploration of that data set first to get an idea of what the values are and what you might, your expectation of what that data is might be very different than what R is actually loading and what it thinks the data is. So, and I'll show you an example of that shortly of where that conflict can happen. Now, Since we're going to be using this funct reorder function later on, I want to show you an example of that now in tidyverse. This is from the 4cats library, and I need to find out why they called this the 4cats library. I don't know why, but I could not find the answer. But it's an interesting name for the package. I showed you this figure before, where we have species here on the x-axis, and you'll notice it is sorted by alphabetical sorting. S comes before VE and VE before VI. But what if you wanted to organize this differently? What if I wanted to organize this based on the median value of the sepal width? So therefore, it would be something like versicolor first, then virginica, and setosa. There you can use the function called FCT reorder. This would be like for factor reorder. The 4cats package is a package for manipulation of factors specifically. So there's a lot of specific functions that deal with factors in there. And one of them would be is to reorder species based on the sepal width. And let's execute that. And there's the change in our graphic. So it allows a dynamic reordering of this factor based on some other value. Okay. All right. Let's move on to some other tidyverse usage. I'm going to show you this MT cars data, another data frame that comes with R. And MT cars shows us some information about like 30 or so cars, miles per gallon, the number of gears, the carburetor size. And what I want to show here is without tidyverse, how would I be able to add a column to this data set, let's say? Let's say I want to add the value of the miles per gallon divided by the weight. So if I calculate that, here I get that vector of the miles per gallon divided by weight. What if I can add it to the MT cars data frame by just specifying a new name of a variable here after the $ notation. And when I then look at MT cars, we can see it's been added on in this column on the right-hand side. In tidyverse, you use the function mutate. And the first argument to mutate would be the data frame MT cars itself. And then you specify here how it's calculated, or you give the name of your new column and then specify how it's calculated. So here we don't have to say MT cars $ MPG wild type or $ MPG. It's just using the names without specifying the data frame since it's already here. And doing that now, and we can execute MT cars, and it has added that to the end of the data frame. Okay, then moving on to how you can select various columns. There's a function called select. And now I'm introducing this very handy pipe operator. So the % greater than % is called the pipe operator, where what that says says take the MT cars data frame and pipe it into the select function, kind of like just like the flow of water through a pipe. So MT cars is being flowed, through this pipe into the select function, and then it's saying show me the MPG and cylinder columns. So we do that, and that's what we get. We just get those two columns. I'm going to skip a couple things, and then if we want to filter, let's say we want to filter MT cars the old way without tidyverse. We would have to use this subset notation to where we are saying, well, give me empty cars, where empty cars MPG is greater than 21, comma, give me all the columns. If you remember how I was saying, if you don't specify anything after the comma, you'll get all the columns, and we do that. Everything over 21 MPG we see now in our display down below. Here, it's just empty cars piped into filter. Give me everything with greater than 21 MPGs. Okay. And I'm quickly going to say, I won't execute these at the moment, but there are sorting functions. There are renaming functions to rename columns. You can summarize your data set in various ways.
Sorry, Paul, you accidentally muted.
Unmute. Okay. I wonder how I did that. Okay. So I'm going to skip down to the flights data set. That comes from the NYC Flights 2013 data, or that library. And I'm going to just set F is equal to flights to make this easier for me to have typed out some of these the code examples. And what you'll see is that F here in the global environment for the flights, there are 336,000 observations across 19 variables for the flights data set. And I want to use the describe function here, again, from that HMIS package for this data exploration. So anytime using a new data set, it would be best to take a look at this. Now, the output is going to be, there's a lot of output here, but you would want to take some time to look at your data and see what each column is, how many things are missing, what these values look like. Just really helps. Again, I know I keep stressing that it really helps for data exploration. And one thing that we'll notice here is I lost where I was. I'm going to come back to that. I'll get to that in a second. It's probably best if I wait on that. But so back to just the data frame itself, F. I want to show here in this data frame, there is 3 columns for the date: year, month, and day. They're separated. So how would we create our own date column? Here, then, we could use the mutate function, where we are making a new column called date, and using the paste 0 function that I showed before, where we would just say, put together this value as the month here, like month 1, connect it to day with a dash, so 1-1-2013. And doing that, if I just run this highlighted part of the code where I'm saying F type into mutate, if you look down at the bottom of your screen, see how this time hour is the last column of this data frame. When I go back to here to do that, we should see date appear at the bottom. So date now is added on at the end. Okay, but I want it to be at the beginning. I want to see date at the beginning of my data frame. So now we can see where the power of this pipe comes in, is now we can just flow this output of mutate into the select function. So by highlighting everything here, we can select date as the first column and then give me everything else. It's another helper function from dplyr in the tidyverse. And doing that, I've reset my value of F so that now if I highlight F and execute it, now we have date at the beginning. But date, unfortunately, is still just a character value, CHR. And I want to convert it into an actual date. And that's where the lubridate package comes into play. I've already executed that library lubridate, so that is in our environment. And now one of those functions is to say, convert this character date into a real month, day, year date. And I execute that. And when we look at it, date is now in a date format. Okay. And let's see, I'll skip a couple things here. Let's just do some more filtering operations, such as something like this with an R, that the AND operator, when you want to say, well, give me all of the flights on January 1st, we can specify month as 1, day as 1, and say, so that means every row, month has to equal 1 and day has to equal 1. And we can filter that and get that value. There's an OR operator, so month 11 or month 12. We can do that, and that will give us all of the flights, 55,000 of them in December or November. And then some other more, let's say, I guess, advanced operations with tidyverse is to ask some questions like, well, how many flights are there on each date? Okay, so this is a data frame or data from the year 2013. How many dates would you predict that you would get if you would group all of these observations by date? Well, if it's kind of a full data set for a full year, you would expect 365 dates, one for each day of the year. So if we take F, pipe it into this group by date, and execute that, tidyverse tells us here that, yes, we do have 365 different unique values of that date column that we created. And then that can be piped into a summarize function to then, and these are just all these other little helper functions in tidyverse that you get to learn. And is this N function is the number of observations in each of these groups. So we can summarize that and boom, it kind of just one row for each date telling you 842 flights on January 1st. And that's how you find that out. Now, count is a much, for something like this basic group by and to summarize for how many number of something is, count is much easier. So count can simplify that. You could just say, give me the count on group by date and just call it number of flights. And that gives you the same output. But you can't use count for something like if you want to do mean airtime on each date. So, so what was the, on each date, what was the mean airtime of all those flights? So we still have to go back to group by to summarize. Okay, so when I do that, why am I getting NA values here? So this is a surprise. Airtime. Let's use that HMIS function describe on airtime to get us an idea of what's going on. So when we look at airtime, we see that there's 9,000 odd number of missing values. Okay, and so that's the first red flag. There is, okay, there's some missing values. Then we also ran this function mean, which you want to know, well, how does mean really work in R? So if you had a missing value and you're trying to calculate the mean of a set of values, but some are missing, how do you define the mean for a set of values where, there's not all the values are present or there? And so mean, if we do this to look at the help function for that, you can see this NARM is equal to false, meaning that the default says keep NA values in the calculation. And therefore, a mean of any set of values that have NAs in them comes back as NA. So you can then specify NARM is equal to true to then allow this to really work. So if I execute that now by here's what I had run before, and the only difference here now is to I'm adding in NARM is equal to true. So now we can get a real error time for that. And I'm going to skip over this, and I'm going to get onto this because I want to get into some ggplot for the last 10 minutes or so. Is a quick introduction into tidy data a little bit more, as I mentioned when I first started tidyverse. Was okay. Why is tidy data needed? This is not going to totally answer that for you, but I'm going to show you what tidy data is. Okay. Table 4a is a table provided by tidyverse when you load it, so it's already in your environment. And if I execute just that table itself, I hope everybody can see. Let's just make that a little bigger. Yeah. That down here in the lower left, it is a very small data frame of 3 rows and 3 columns. There is a country column and then 2 year columns. So the years are specified in columns. So if you had more years in this format, you would have a 2001 column, 2002, 2003. So that this data would be what's called wide data, that you would have this a wide format. But tidy data is is more into what's called a longer format. And that's why tidyverse has a function called pivot longer to help you reformat your data into this format. And pivot longer will then, and I have a picture of that here in here. I'm not going to be able to go through this in detail here, but take a look at this. This helps to visualize this a little bit more. And I'm going to go back to RStudio and just go ahead and execute this. And if you look now down at the bottom of the screen, it has taken the year values and put it into its own column. So tidy data, you want all of your variables in a column. So instead of having the variable year in its own separate column, the year itself is in a column by itself. And now you've duplicated Afghanistan twice because there was 2 years for it. But we're going to see very shortly here in ggplot why this was important. So I'm going to now switch to doing some ggplot stuff. That would be on this next slide, just to give you some links for reference. There's a reference documentation link here. ggplot is it's almost, yeah, it's like a little language of itself. It's actually, it's called the grammar of graphics. So how do we discuss, or how do we talk about graphics? What are the verbs, nouns, adjectives in terms of how do we build beautiful plots? And it kind of starts with your base data to build it up with various aesthetics, geometries, facets, statistics, how to manipulate the coordinate systems, how to apply themes such as colors and shapes. So I'm going to show you some of that shortly. There's an aesthetic specification link showing you kind of what shapes and colors are available. And this R Graphics cookbook, which I highly recommend, that I cut my teeth initially on this open source book on the web that really is organized really well. Showing you loads of examples of how to do things. So it's kind of in that cookbook recipe style. Okay, so let's jump back to R and load up one of these for ggplot. And I think we probably should be able to get through this one before the end, I think. So, okay, so again, loading our tidyverse, loading our HMIS package to do data exploration again, and another data set called college. And in this college data set, again, here it's a new data frame, let's say. I'm just starting to work with it. I want to describe this data. And I'm sorry, let me show you college, for instance. Here is kind of some tuition information, admission rates, if it's public or private school. And one of them is this loan default rate, which is a character vector, which sounds a bit odd because loan default rate sounds like it should be a number, some kind of decimal value, but not a character value. So if we look at the describe function on that column, or on that vector of values for this loan default rate, we can see that there are some nulls in there. And nulls are going to throw off the ability of R to detect that this column really should be a numerical value. So that when read CSV, when it's reading in this data set, it's really converting this loan default rate into a character because it sees this null value. And when we execute just this vector here to look at all of the values, you can see the numbers are in quotation marks, which means that they're being treated as strings. They're not really being treated as numbers. And I think somewhere up here, there's a null value. Yeah, you can see it right here. And one way to fix this is we can coerce this using some base R functions here called as numeric. So I'm going to reformat the college data frame, coercing loan default rate as a numeric. And now when we do that, you can see there is a warning message. It is telling us that NAs were introduced by coercion. But NAs in R in numeric vectors are what we want. That's fine. That's how we can specify missing values in numeric vectors, is with NA rather than null. So, okay. So let's move on to ggplot. ggplot will allow us to do a simple scatter plot such as this. Let me break this down for you. The main function ggplot, we give it our data that we want it to plot, is the college data frame. And if I just execute that on its own, it sets up a graphical window over here, basically with nothing in it, because we didn't tell it to do anything with this data other than this is the data. Now we specify these various geometries. Like I want a scatter plot, which is geometry points. And now we tell it, well, what do we want on the x-axis? What do we want on the y-axis? The column names. And so I just want to look at tuition versus SAT average. And there you're getting this default circle for the point and the tuition and SAT average. We can look at other dimensions of this data set with other aesthetics, such as shape, such as color. So let's take a quick look at that, where we are going to apply basically we're going to change the shape of these points to the control column, which is the name of the column, not so well named for the public versus private schools. So either control is equal to public or private. So when we add that in there, we can see now it's changed private. Well, it's kept private as the default circle, but then public is now this triangle, which is harder to see. So let's switch that to color aesthetic on control. And that is much easier to see. Now we have some cyan for the public and red for the private. And we can also switch to our own colors using scale color manual. And these functions are all just found by either Googling and saying, how do I change my colors to what I want in, you know, in a scatter plot for ggplot. And so now I want to say, let's change them to green and blue. So I execute that and I get that. And I'm going to, we're running out of time here. I'm going to then just show you two final things. One here is to, where I've added on some of these other things like scale Y continuous, which gives me where I can say, well, display this value 1400 with a comma. You know, if I don't put this in here, we were getting just 1400 without a comma. But if you want to manipulate your scales, you can do so. We can also do this facet wrap, which is pretty cool that it breaks these things out into by control, by private versus public. And so it gives you a panel for each of those, as well as this alpha variable, which helps for this transparency, which can make that look a little better. And I want to finish this then by just going back to that tidy example. So let's wrap this up with back to that table 4A, where we had the years in each of its own independent columns. If I want to plot this, I would have to specify one geom point line for every column of data. If I would have 10 years and I wanted to plot all those points across those 10 years, I would have to put geom point 1999, geom point 2000, geom point 2001, and it would get to be a little ridiculous. So if I show that, it does work by adding geom point this, geom point 2000. We can see that here, that all the points are displayed. I haven't colored them, but by doing the pivot longer now, going back to this, showing that long transformation, the year is now in its own column. Now I can say, which is the magical thing that happens here, is to color by year. And now one geom point one geom point function, coloring by year now allows that to occur, that you can see the 2 years displayed. I think with that, I think we should wrap that up and then we'll proceed tomorrow. So that'll be it for today then.
Excellent. Thanks, Paul. Are there any questions for Paul before we wrap up?
I have a quick question.
Yeah.
So I've heard from mainly my brother that the use of Anaconda Navigator could be good. What are your thoughts on that?
Oh, can you say that again, please? I missed that.
What are your thoughts on Anaconda Navigator?
Oh, Anaconda?
Yeah.
Yeah, I haven't used Python a lot. Unfortunately, I won't be able to speak to that. I don't know.
Oh, okay. Because my brother was talking about how he was using it for our studio, and I was just wondering. So that's fine. Thank you so much, sir.
Okay. Yeah, you're welcome.
Any other questions? Okay, then with that, I'd like to thank Paul again for being here, and we look forward to your talk tomorrow. Students in Journal Club Group 1, if you are here, the interpreters are here as well, so you can feel free to use this channel to work on your journal club. I know yesterday you had hoped to do some. That's going to be true for tomorrow too.